Alright guys, this is the video for Learning Target 4. You might be wondering why we skipped from Learning Target 1 and 2 to Learning Target 4. We're going to come back and cover 3 and finish up 1 and 2. We just thought it was good for us to go into solving here, and then after we've solved we can make more sense of those learning targets again. So we're going to get into solving quadratic equations. The first thing we're going to do today is solving using just square roots. So a question that we might want to answer is, why do we solve equations for y equals 0? Well, we've already talked about a parabola looks like this. So when y is 0, this would be where we're solving. We're solving for these 2 points. And in our last video and in class we've talked about those are called the roots. And there's a couple different situations here. You may have 2 roots. You'll most often, I suppose I should say, have 2 roots, but then you might have 0 roots. If your parabola is moved over and up, this parabola will never cross the x-axis, so we will have 0 roots. Or you might just have 1 root, and that would be the case when your vertex is on the x-intercept. And so your vertex is the only part of the parabola where one y does not have 2 x values. So we could have 2 roots, most commonly have 2 roots. Sometimes we'll have no roots, either that parabola or something over here or something over there. Any of those 4 will ever hit the x-axis. Or we could have 1 root, so that parabola or a parabola that hits it on the way up where its maximum or its minimum are on the x-axis. Okay, we solve quadratic equations for y equals 0 to find our roots, because in the last video, or in class, we learned that from the roots we can then find the vertex, and if we have the vertex and the roots of a parabola, we are sitting pretty good. We can graph it, we can tell a lot if we have those 3 pieces of information. So we're going to move on to some examples here. We're asked to solve each equation for x when y is 0. So basically we're finding the roots of each of these parabolas, and we know they're parabolas because they have a leading coefficient with x squared. Our highest exponent is x squared. All x squared equations will give us a parabola. So if I plug 0 into this equation here, we have x squared equals 16 plus 0. So that's x squared equals 16. Now, the opposite of squaring is square rooting. We know this. So I'm going to square root both sides. And then the square root of x squared is x. And the square root of 16 can either be 4 or negative 4. Because both 4 squared and negative 4 squared are 16. So that's my answer there. I have 2 answers, which makes sense because this parabola, most parabolas, you're going to have 2 roots, and this one will be at negative 4, and this one will be at 4. Okay? Moving on over here, we have x squared minus 81 equals 0. Plugging 0 in for x. So if we add 81 to both sides, then x squared equals 81. And we square root both sides. X is going to equal 9, or x equals negative 9. Again, this parabola is just going to be out wider, where its roots are negative 9 and 9. Okay? Moving on, this one looks a little more complicated, so let's first plug in 0. So we have the quantity x minus 2 squared plus 1 equals 50 plus 0. Okay, if I subtract 1 from both sides, then we have quantity x minus 2 squared equals 49. Okay, now right here we can't do anything inside this parentheses before we get rid of this exponent. So I'm going to square root both sides, and the square root of x minus 2 squared is just going to be x minus 2. The square root of 49, however, is either 7 or negative 7. So this turns into 2 different equations. X minus 2 can either equal 7 or x minus 2 can equal negative 7. So from here now I have to solve to find my two different answers, because this is going to give two different answers. If we add 2 to a 7, then we're going to have x equals 9. If we add 2 to a negative 7, add 2, then x is going to equal negative 5. So those are my answers here. Those are my roots. So this would be a parabola that has a root of negative 5 and positive 9. All right. So if you need to, take some time, look through that, and then use that to try to solve these three equations for class.